Tonight in Arkansas, there's a mother tucking in her daughter and turning off the light. A business owner's burning the midnight oil. An at-home dinner date is plating up possibility. And it's all happening under one roof. How? The power of a conversation, like the one John from Integrity Solutions had with First Horizon Bank about his vision for a sustainable mixed-use building. Now it's not just words, it's life. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John. First Horizon Bank, member FDIC. Recently, our client John met his banker to discuss plans for a clean energy building. What he found was a shared passion for building something more. Momentum for change. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello, thanks for joining us. This is the Space Nuts podcast. I'm your host, Andrew Dunkley, and joining me every week without fail, because he has no choice, is Professor Fred Watson, Astronomer-at-Large. Hello, Fred.
Yeah, the choice disappeared years ago. I should have said no right at the beginning, shouldn't I?
Yes, well, it would be easy to say no when we don't have an audience, but now that we have, 3 people that listen.
I know, well, we've talked to all of them, so that's good.
Yeah, including Gregory Peck. It's just hard not to do it. But we do get some nice notes occasionally. Had a beautiful note this week from a fellow who's only just discovered us and is binging, and he finds it most enjoyable. So we appreciate that kind of feedback. You can send hate mail as well to Fred. But other than that, we do like to hear from you in whatever form. Now, today, Fred, we're going to find a space probe, one that was due to land on the moon in September last year, but it landed a bit too heavily and became what is officially known as wreckage. But it looks like they've found this particular probe. It was launched by India. So we'll learn about that. And this rather interesting story about how some of the rivers on Mars may have formed under sheets of ice, suggesting that Mars had its own ice age, perhaps. We'll also be looking at some audience questions. One about, I kind of like this question about the Hubble Space Telescope, how it's able to take such brilliant images of things that are light years away, and yet why can't it take a nice close-up of Pluto? That's a really good question. And we're going to talk about long-haul space travel and whether or not going from one place to another could be, even if you could travel at near the speed of light, could the journey take longer because of the expansion of the universe? Somebody's thinking way outside the box, and it wasn't me. So we'll get to all of that. But first, Fred, let's look at the Chandrayaan-1 lunar orbiter and the unfortunate demise of the lander in September last year.
Yeah, that's right. So a mission from the Indian Space Agency, which is ISRO, if I remember rightly. The Chandrayaan mission was designed to land a rover on the surface of the moon, not far from the South Pole. But I think you and I covered this at the time, Andrew, that basically the Indian Space Agency lost contact with the spacecraft around about the time of touchdown, and the suspicion was that basically it had crashed on the surface, and all that there was a pile of wreckage. However, there is somebody who's described as a techie, which I think he's an engineer actually, in Chennai. His name is Shanmuga Subramanian, and clearly an amateur space enthusiast of great talent, I have to say, because he used NASA Lunar Reconnaissance Orbiter images that were made in November last year to identify the debris of the lander that carried the rover. And just to put a couple of other names in, the lander was called Vikram. It was named after one of, I think, the actual founding scientist of the Indian Space Agency. And the rover was called Pragyan. And I'm not sure what those names mean. I think they're Sanskrit, but that's beyond our remit at the moment. Shanmuga Subramanian, the man who was looking at these images, he identified what he took to be debris from the Vikram lander, from these lunar reconnaissance orbiter images that were released last year. And that, I think we probably covered that as well, actually, in our wide-ranging talks. However, there were more lunar reconnaissance orbiter images of this region released, I think it was in January. Yes, January. That they were taken on January the 4th, but made public in May. And because of changing light conditions, and remember, these are near the south pole of the moon, where the sun angle is very shallow. Because of the changing light conditions, the January images revealed much more detail than the November images. And so Shanmuga has had a good look at these and now believes that what he's seen is that, in fact, the lander made a soft landing. What he says is, going by the January 4th images, which were made public in May, I think Pragyan may be intact, and Pragyan was the rover. I think it may be intact, and that it has rolled out a few meters from the lander. We need to know how the rover may have moved, and I hope ISRO is able to confirm this. So he's, pored over these images and done some very clever analysis. I think he's done some, he's used algorithms that tease out the detail in these images, and it almost looks as though the thing made a soft landing, and the speculation is that the spacecraft itself sent the command for the rover to essentially to be deployed from the lander. So the rover and the lander were communicating with each other autonomously, but they'd already lost communication with the ground station back here on Earth. So nobody knew about that.
So we just naturally believed that something catastrophic happened. The thing perhaps crashed or landed too heavily to be functional, and that's been the belief up until now.
That's right. Yeah, it's got echoes, Andrew, of the Beagle 2 story, which you'll remember was launched from. It's a British spacecraft, a British lander on Mars, which was launched or deployed from the Mars Express spacecraft, a European spacecraft. That deployed Beagle 2, which went down to the surface, landed, and was never heard of again, basically, for about 12 years. And everybody just thought it was lying in millions of pieces on the surface of Mars, until Mars Reconnaissance Orbiter came along with its high-rise camera, the high-resolution camera, and could see an image of this thing sitting on the surface, almost fully deployed, but one of the solar panels had not folded back. And so its antenna was unable to send signals back to Earth to say, I'm here. So
I'm here. Throw me a bone.
Yes. Once again, a near miss event.
And it doesn't have to be a big catastrophic error. It can be as simple as, like you say, a solar panel just not quite getting where it needs to get, or could even just be a loose wire. It could be anything. It could be so minor, and it could completely ruin a multi-million-dollar project.
That's right. So I think this is really interesting stuff. It's kind of forensic science, detective work done after the event. It seems unlikely that the Indian Space Agency will be able to wake up, the Vikram lander to get communications. Apparently, they tried many, many times, but
Well, all they've got's radio. So
Yeah, that's right.
as wonderful as radio is, it can't physically move something.
No, exactly. And especially,
that may need to be moved.
if it's the link between the Earth and the lander that is broken, and it sounds as though that's it. Doesn't matter how well the rest of it's working, you're never going to know what's happening. So yeah, but very interesting that they may have come within a whisker of success with Chandrayaan-2.
Yeah, that probably won't make the government feel much better about the investment, which was many millions of dollars.
It actually it was millions of dollars, but it's much cheaper. That Indian mission was one of the cheapest space missions to another world that's ever been done. They managed to do it.
And what was going to be their goal? What were they hoping to achieve?
So it was a rover, rather like the Yutu-2 rover that's currently the Chinese rover that's on the far side of the moon. Investigating, it would have had cameras. I think it had analytical equipment to sense the makeup of the rocks that it was on. I'm not sure whether it had ground penetrating radar, because that's one of the really interesting aspects of the Chinese missions, that they've got ground penetrating radar on board their rovers. I'm not sure whether the Vikram rover had that.
Okay, so
Pragyan, the rover was Pragyan. Vikram was the lander. I'm getting my vehicles mixed up here. Yeah,
that's okay. You're getting your curried sausages mixed up with your chicken tikka. That's what's happening. But will they try again? Do you expect that the Indian Space Agency will mount another mission, or?
Yeah, I think it's inevitable that they will. I think there's probably a lot of work going on behind the scenes in India in their space. The Space Research Agency. They're probably. I don't really know, because I haven't got any contacts there, but they're probably working at a reduced rate, as most of us are because of COVID-19. But it's a very ambitious and very efficient space agency with big ambitions. So I'm sure we'll hear more, Andrew.
Yeah, I think it's great that more and more countries are getting involved in space exploration, because it can only make it better and better into the future. And, if somewhere along the line there are more and more collaborations, better still, as far as I'm concerned. I think that's a good thing.
Indeed, I agree entirely.
Yeah, well, competition never hurt anybody, did it?
Oh, that's right. And collaboration's great too. We see that in the International Space Station, that has many nations cooperating.
Okay. All right. Well, they've found it, but unfortunately they can't make it move, which is very, very sad. And I suppose one day someone might walk around there and have a look and go, that little thing fell out, and plug it back in, and hello.
Just a
away we go. It is possible, I suppose. You're listening to the Space Nuts podcast with Andrew Dunkley and Fred Watson.
3, 2, 1.
Space Nuts.
As always, I'd like to say hello to everybody who supports us through whatever social media platform you prefer. And, of course, many of you listen to us through YouTube, and we appreciate that. So if you'd like to be a YouTube subscriber, just do a search for Space Nuts Podcast in your YouTube search engine and subscribe there. You can catch up on all the episodes. I think I've said before, all you have to do is hit play and it'll just run the whole damn lot of them back to back. You can listen to all 214 episodes non-stop if you want to. And, of course, Facebook, very popular platform for us with the official Space Nuts Facebook page, but also the Space Nuts podcast group, which is continuing to grow. And that's where you, as a Space Nuts listener, if you so desire, can basically chat with other Space Nuts listeners. It's a group especially for you to talk to each other and compare the size of your telescopes and all that sort of stuff. It's a fun group, and sometimes they do some interesting things, such as showing a rooster in a spacesuit. We've got somebody did up a photo of what is purported to be Gregory Peck in a spacesuit. And that thing has gone absolutely nuts online, Fred. It's a funny picture.
It's
And
curious.
yes. But I did tell you that Gregory Peck would take the world by storm. I notice he's already made a cameo today. So,
He has.
yeah.
He's not quite as he was right outside the door when he made all that noise a couple of weeks ago, but he's down the paddock at the moment. But
Okay.
I'm sure we'll hear from him again.
Oh, don't doubt it. Yes, indeed. Now he couldn't get a word in when Mandu was around, but now he's taken centre stage. Now let's get on with it, Fred. We're going to go back to Mars. This is a fascinating place, and we do know that it had oceans and rivers and all sorts of stuff that we know and love on our own planet. But now it looks like it might have had an ice age, and that some of these river valleys may have been formed under sheets of ice. That is a very interesting theory, maybe more than a theory.
And it could be quite revolutionary, Andrew, because what this is offering, it's a completely new idea, is the idea that, no, actually Mars wasn't warm and wet 3.8 billion years ago, because that's the current thinking, that, Mars had rivers flowing and a very similar climate to the Earth. And that comes from the geological evidence that has been gathered both by orbiting spacecraft and spacecraft on the Martian surface. This is a new idea that actually puts a slightly different light on what we understand Mars might have been like. And it comes from researchers at the University of British Columbia in Canada, and essentially challenges our view of what Mars might have been like 3.8 or 4 billion years ago. And what these scientists have done, they have looked at what happens beneath the ice sheets of actually places that are in the Earth's Arctic. In fact, they've particularly concentrated on a place called Devon Island. I'm not actually sure exactly where that is, but I suspect it's northern Canada. There is an ice sheet covering that landscape. And beneath that landscape, there are drainage channels. So the pressure of the ice essentially melts the water underneath, which forms channels in the rock. And what these scientists have done is they've made algorithms that essentially make judgments as to the shape and size of these networks of valleys, which we find on Mars. And they've applied this to 10,000 Martian valleys, their new algorithm, and looked at how their shape and the dimensions compare, with channels on the Earth that are known to have formed under ice sheets. And so one of the authors, here's a quote from him, Mark Jelinek, who is a professor in University of British Columbia's Department of Earth, Ocean and Atmospheric Sciences. He says, "These results are the first evidence for extensive subglacial erosion driven by channelized meltwater drainage beneath ancient ice sheets on Mars. The findings demonstrate that only a fraction of valley networks match patterns typical of surface water erosion, which is in marked contrast to the conventional view. Using the geomorphology of Mars's surface, the shape of Mars's surface, to rigorously reconstruct the character and evolution of the planet in a statistically meaningful way is frankly revolutionary." So what he's saying is that most of Mars's valleys were formed not by rivers running, essentially in equilibrium with an atmosphere, but by meltwater underneath glacial ice sheets. And that is a completely new picture of the way Mars might have formed its river valley networks. There's still, I think, room for the planet having had a liquid water ocean, because we find there are features on Mars which are really characteristic of coastal erosion. So I don't think the idea of Mars having at some stage being warm and wet has been thrown out entirely. But what these guys are saying is that most of the valleys we see on Mars may well have been formed underneath ice sheets. So exactly as you said, an ice age on Mars that might well have been the time when most of those valleys were formed. excuse me, Andrew, got the terrible frog in the throat again. It's really a very interesting piece of work, but there is a surprise to it as well, and that is the comment that if you did have, these drainage valley networks underneath ice sheets, they claim that environment would actually support better survival conditions for possible life on Mars. So you've got a sheet of ice, and it's giving you more protection from things like solar radiation, and it makes the underlying water more stable than perhaps it would be if it was open to the atmosphere. And so the suggestion is that we shouldn't be despondent about this, that this might have been a place where Martian life would have thrived rather than, being open in a surface environment to all the horrors that the sun throws at the planet. So a really interesting new set of data.
I was wondering about that because I was thinking, well, this story's come out just a week after they've launched their probe to Mars from NASA to look for life in a river delta, and now we hear this and they'll go, oh, great. No, great. What are we going to do now? We can't land there. But it might actually be better. It might turn out to be a more likely scenario.
Yeah, so that river, I don't know enough about the mechanics of glacial drainage, but it's possible that river delta might have been under an ice sheet. We know that river delta is made by water flowing into Jezero crater, which is where the spacecraft is heading for, Perseverance. I think it may well be, Andrew, that when Perseverance gets to work early next year on the surface of Mars, it might actually be able to give an answer to this question, to say, yes, we've got definitive evidence that these channels were formed by subglacial ice. I don't know whether the 7 instruments on board that spacecraft, whether they're able to do that, but it is possible that we might certainly get clues about the real nature of what these water flows were doing on Mars.
And obviously the way water forges out its rivers and valleys under ice is very different from the standard erosion that we know from exposed weather situations, I suppose would be the way to put it.
Yep, that's right. I mean, there are some, there are canyons on Mars which have probably been caused by water flow. Were they formed under ice? We don't know. They're really interesting questions. It's kind of, opened up probably a can of worms, really, but it's provided a new picture of what ancient Mars might have looked like.
Yes, indeed. Well, even ancient Earth was very different to what we're experiencing now. You look at it, one of the iciest places on the planet, Antarctica, and it's believed that at one stage it was tropical.
Yes, that's right. Indeed, it was. But at one stage, there was, the Earth did go through a period when it is called the snowball Earth period, when it was essentially iced up completely. And it's all to do with the way the atmosphere behaves. Really interesting stuff.
Indeed. Well, it stands to reason that it's probably been the case on Mars as well, and hopefully some of these questions will be answered by these 3 missions that are headed that way, and we'll start to get answers into next year. And you're listening to the Space Nuts podcast. Andrew Dunkley and, of course, Professor Fred Watson.
Roger, you're loud and clear here also.
Space Nuts.
Thanks to our patrons who have been supporting the Space Nuts podcast financially. We appreciate whatever you're willing to put into the program, so thank you for that. Whether you do it through patreon.com or Supercast, it's up to you. Some prefer one over the other and vice versa. It doesn't matter. But if you would like to sign up to be a patron, you can find all the details on our website, spacenutspodcast.com. That's spacenutspodcast.com. That's our official URL now. Got a note from someone the other day to say that they will be becoming a patron. And of course, as a patron, you get bonus material, and we'll be adding some more material in the next little while to for our patrons. Plus, you get a free edition, commercial free edition, and you get it ahead of everybody else. Basically, we give you an early release version of Space Nuts. So thanks again to our patrons for supporting us. You can put in as much or as little as you like. But as I always say, it's not mandatory. You do not have to. It is a voluntary situation. So we appreciate your support either way. Now, Fred, let's get on to some questions. And this one comes from Zachary Stoper. Hi, boys. Love the podcast so much. His question is, from a telescope perspective, how can the Hubble capture such amazing deep space, magnificent images, yet not focus on local planets in detail? I would think from a layperson's perspective, Hubble could image Pluto in great detail, but this is not the case. Will the James Webb Telescope be able to detail local images? That is a really interesting question, and one I must confess I never thought to ask, but it makes perfect sense to think that something capable of taking crystal clear images of things that are light years away would be able to do an even better job of something that's light hours away.
And indeed it does. So the best images we have, apart from ones taken by spacecraft, of the planets have all come from the Hubble Telescope. In fact, the Hubble published a couple of weeks ago, I think it was, some stunning images of Saturn, and the detail in them is just astounding. So the issue here is that these deep space images, you're looking at things whose dimensions are measured in light years, enormous things at enormous distances. When you're looking at the planets, you're looking at smaller things at smaller distances, but it still resolves the same detail. We measure what we call the resolution of a telescope, the amount of detail it can see. We measure it in terms of arc seconds. The 1 arc second being 1/3600th of a degree. I can't remember off the top of my head what the resolution of the Hubble telescope is, but it's in the region of a tenth of an arc second, probably rather better than that. In fact, it might even be more like 100th of an arc second, that sort of detail. And so it doesn't matter whether you're looking at something near or far, you still see that angular detail on it. So small objects relatively nearby give up their secrets in the same way that large objects a long way off do.
I've found it. It says it's about 1/20th of an arc second.
There you go. Okay, so 0.05. Yeah, thank you for checking that. Typically, on a good ground-based telescope, you would be looking at a resolution of not much better than 1 arc second, unless you use this technique called adaptive optics, which cancels out the turbulence of the atmosphere, and the big new telescopes will use that. And in fact, some of these ELTs, the big new generation of extremely large telescopes, the ground-based ones, they will actually beat the Hubble in terms of resolution. It'll be better because they're bigger telescopes. A bigger mirror in a telescope increases your resolution. But of course, against that, you've got the atmosphere. And so on a ground-based telescope, you need to use the adaptive optics technique. This is all something we'll be seeing within the next decade with the European Extremely Large Telescope and the TMT, the 30-meter telescope, and the Giant Magellan Telescope, the 3 ELTs. We'll see exquisite imaging comparable with the Hubble. Zachary mentions Pluto, and you can actually see, I've got a montage that I used to use in talks that shows how our view of Pluto changed. And the Hubble image of Pluto was basically about half a dozen pixels, because Pluto is a tiny world, smaller than our own moon, and it's at 5 billion kilometers away. That's why you don't see more than a few pixels with the Hubble telescope. And that's why it was so crucial to get a spacecraft out to Pluto to find out what it was really like. And of course, that was New Horizons. Back in 2015, it did that marvelous job of showing us what Pluto was really like.
Yeah, so it's not really a question of the distance. It's a question of the size of the object per the distance.
Exactly. That's exactly what it is.
So if Pluto was like as big as Jupiter or something, we'd get much more stunning images of it through Hubble.
Yes, that's right. That's precisely the case. But it's tiny. Pluto's a dwarf planet.
Yes, indeed. Okay. So there you go, Zachary. Hopefully that answers your question. Oh, he also asked, if we can expect even greater detail from the James Webb Telescope. And I imagine the answer is yes, because it will be so much more advanced and so much more capable.
Yeah, in fact, the secret is that it's bigger. James Webb is a 6.5 meter diameter telescope. The Hubble is 2.4 meters. So that kind of tripling of size in itself gives you an increase in resolution. Against that, actually, is that resolution, the fine detail that you can see actually deteriorates with wavelength. So as you go into the infrared, you actually lose resolution because visible light has a shorter wavelength than infrared. So there will be a slightly negative effect because the James Webb Telescope is an infrared telescope, but we'll still see some fabulous images from it with detail, which will certainly be better than the Hubble.
So it won't be able to take a photo of Pluto either?
It'll be, a bit better, but not much different. No, that's right.
Okay. I'm sure it's looking for bigger and better things way beyond our solar system. So that would make sense.
But,
all right.
Scientists will use it for solar system observations. I mean, we'll learn things from the James Webb about our own solar system, which will be great.
Yes, indeed. Very much so. Thanks, Zachary. Great question, though. Gave us a chance to explain that situation. And that's Gregory Peck ringing Fred.
I wonder who it might be.
Let's move on to our next one from Jeffrey Bierman. Hi, Jeffrey. Thanks for this question. This is really thought-provoking. I like this. Jeff is from Colorado. If we gained the ability to accelerate a probe or generation ship or other spaceship to 0.25 to a destination 100 light years away, 100 light years away, so 0.25 of the speed of light, would the ship be delayed by the amount of the expansion of the universe during its 400-year trip? So you do 0.25 the speed of light, you're traveling 100 light years, and that would equate to a 400-year journey. But is there something that's going to influence that and slow you down, such as the expansion of the universe? That's what Jeffrey is asking. That is a really interesting question because we talked about the expansion of the universe, and that's happening faster than the speed of light. So is that going to create an increase in the distance between the objects you're travelling over the 400-year time frame?
So it is a great question. And the answer is yes, it will, but at a microscopic level.
I'm going to say that.
Yeah, I'm sure you were. So what Jeff is postulating is, you accelerate your spacecraft to a quarter of the speed of light. That's 75,000 kilometers per second. And you do this 400-year trip to get to a destination 100 light years away. That's a pretty high speed. So the expansion of the universe, which is kind of taking place, the spacecraft is moving through the universe is expanding. Is that expansion going to increase the length of the journey? And what you have to do is the calculation. So the expansion of the universe is measured by something we call the Hubble constant, h0, which at the present time, because it's varied over the history of the universe, but at the present time, h0 is about 75 kilometers per second per megaparsec. Now, a megaparsec is 3.26 million light years away. 1 parsec is 3.26 light years. So a million parsecs is 3.26 million light years. So the expansion of the universe over a distance of 3.26 million light years, or the speed of expansion is 75 kilometers per second. So a 100 light year trip on that scale is completely irrelevant. It's the expansion of the universe. It takes place over very, very large scales indeed. So you'd have to be going to other galaxies by means that we don't have at the moment in order to notice any difference in your journey time because of the expansion of the universe. I'm not sure whether I've made that clear, but what it's saying is that over distances, even distances within our own galaxy, the expansion of the universe is irrelevant because it is so slow.
Yeah, so there is an effect, but it's minute. You'd have to be travelling a heck of a mega long way for it to start becoming a factor.
Right. Yeah, so you really only start seeing the effect of the expansion of the universe when you're looking at galaxies millions of light years away. Then you can start to see it, rather than
and
light years away.
Yeah, and a heck of a mega long way is an official unit of measure, by the way.
as ratified by the International Astronomical Union, yes.
Yes.
Gregory Peck. Their Christmas party last year.
That's where it would happen, most definitely. Yeah. Yes. There you go. Hopefully that has solved your puzzle, Jeffrey. You can jump on a ship at 0.25 light speed and get to where you're going 100 light years away in 400 years and a very little bit. So it's not going to make much difference. You'll still be able to catch your bus. And thanks for the question. It was very enlightening. And thank you, Fred. That wraps us up for another week. It was short and sweet this week. We got through it rather rapidly. I'm not used to that.
That's all right. We're going at the speed of light, Andrew, so we pass places quickly. Thank you.
We didn't even have to allow for the expansion of the universe.
Thank you for having me.
Always a pleasure, Fred.
Yeah, okay. And we'll speak again soon. Thanks very much. Thanks, Andrew.
Yes, we will. And next week, our episode will be dedicated 100% to questions. We'll have some audio questions. We'll also read some out that have been sent the old-fashioned way by carrier pigeon, and whatever means you find works best for you. But if you do want to send us a question, please jump on our website and click the AMA tab up the top. So spacenutspodcast.com, click the AMA tab. And if you've got a device with a microphone built in, you can record your question. Tell us who you are and where you're from and ask your question. We'll try and include as many questions as possible in next week's episode 215 of the Space Nuts podcast, 100% questions next week. Until then, stay safe, and we will catch you real soon on another episode of the Space Nuts podcast.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.